1 light year. Sounds like a journey humanity could one day make. But what if we actually tried? Using the fastest technology we've ever built? How long would it take to travel just 1 light year? The answer isn't years. It isn't centuries. It's something far more astonishing. When you hear the words 1 light year, it's easy to assume it describes time. After all, it contains the word year. But that's one of the biggest misconceptions in astronomy. A light year isn't a unit of time. It's a unit of distance. More specifically, it's the distance that light travels in 1 Earth year. And light is incredibly fast. Moving at nearly 300,000 kilometers every second, it can circle Earth more than 7 times in the time it takes you to blink. Nothing in the known universe travels faster. If even light needs an entire year to cover this distance, just imagine how far 1 light year really is. So, how far is 1 light year? The answer is almost impossible to visualize. Approximately 9.46 trillion kilometers. It's a number so large that it loses all meaning. The moon is only 384,000 kilometers from Earth. The sun is about 150 million kilometers away. Those distances feel enormous to us. But compared to 1 light year, they're almost insignificant. If our entire solar system could fit inside a small neighborhood, 1 light year would stretch far beyond the horizon. It's the kind of distance that reminds us just how enormous the universe truly is. If 1 light year already sounds incredibly far, our nearest neighboring star makes it even more astonishing. Beyond the Sun lies Proxima Centauri. It is the closest known star to Earth. Yet it sits 4.24 light years away. That means the light reaching your eyes tonight left Proxima more than 4 years ago. When astronomers observe distant stars, they aren't seeing them as they are today. They're seeing them as they were when their light began its journey. Looking deeper into space also means looking further into the past. The universe isn't just vast. It's a time machine written in light. For thousands of years, humanity has explored farther and farther from home. We crossed oceans, reached the highest mountains, landed on the moon, and sent robotic explorers beyond the edge of our solar system. But interstellar travel is an entirely different challenge. Before we can dream about reaching another star, we must first understand the distance that separates us from it. 1 light year may sound like a simple measurement. In reality, it represents one of the greatest obstacles humanity has ever imagined. And now comes the question that changes everything. If we left Earth today, using the fastest technology we've ever built, how long would it actually take us to travel just 1 light year? Let's imagine something completely unrealistic. Instead of using rockets, you decide to walk. An average person walks about 5 kilometers per hour. At that speed, reaching 1 light year would take more than 215 million years. To put that into perspective, when the first step of your journey began, dinosaurs had disappeared only a short time earlier on the geological timeline. Entire species would evolve. Continents would continue drifting. Human civilization itself would likely become unrecognizable. And after all that time, you still wouldn't have reached the nearest stars. Walking isn't just impractical. On the scale of the universe, it's essentially standing still. So, what if we use something much faster? A modern car traveling at 100 kilometers per hour would still need more than 10 million years to travel 1 light year. A commercial jet cruising at around 900 kilometers per hour performs much better. Yet even then, the journey would take roughly 1.2 million years. Civilizations have risen and fallen in just a few thousand years. These journeys would last hundreds of times longer than recorded human history. On Earth, these machines feel incredibly fast. But once you leave our planet, their speed becomes almost meaningless. Surely our spacecraft perform much better. And they do. The Voyager 1 spacecraft, launched in 1977, is the most distant human-made object ever created. It travels at about 61,000 kilometers per hour. Even at that remarkable speed, Voyager 1 would need approximately 17,000 years to travel 1 light-year. Even faster is NASA's Parker Solar Probe. At its peak speed, it exceeds 690,000 kilometers per hour, making it the fastest spacecraft ever built. Yet even Parker would still require more than 1,500 years to travel just 1 light-year. The fastest machines humanity has ever created still move painfully slowly compared to the scale of the galaxy. These numbers reveal something extraordinary. The problem isn't reaching another planet. It's reaching another star. Even our fastest spacecraft would outlive countless human generations before completing the journey. Fuel would run out. Technology would become obsolete. Entire civilizations could rise and disappear while the spacecraft continued silently through the darkness. Traveling 1 light-year isn't impossible because of a lack of ambition. It's difficult because the universe is simply far larger than anything evolution prepared us to understand. If humanity ever hopes to become an interstellar civilization, we won't just need better spacecraft. We'll need entirely new ways of traveling through space. Every spacecraft humanity has launched so far relies on chemical rockets. They're powerful enough to escape Earth's gravity, but they're far from ideal for interstellar travel. The biggest challenge is fuel. The more fuel a spacecraft carries, the heavier it becomes. The heavier it becomes, the more fuel it needs. It's a cycle that quickly becomes impossible over the enormous distances between stars. That's why scientists are exploring entirely different propulsion systems. One promising idea is nuclear propulsion. Instead of burning chemical fuel, these engines could use nuclear reactions to generate far greater amounts of energy. They wouldn't approach the speed of light, but they could dramatically reduce travel times across our solar system, and perhaps one day beyond it. What if a spacecraft didn't carry fuel at all? One of the most fascinating concepts ever proposed is called a light sail. Instead of using engines, an enormous ultra-thin reflective sail would be pushed forward by an incredibly powerful laser fired from Earth. As photons strike the sail, they transfer tiny amounts of momentum. Individually, that force is almost nothing. But over time, it could accelerate a spacecraft to astonishing speeds. This idea forms the basis of the Breakthrough Starshot project. The mission's goal is ambitious. Send tiny spacecraft toward Proxima Centauri at around 20% of the speed of light. At that speed, the journey could take about 20 years instead of tens of thousands. It's still only a concept. But for the first time, interstellar travel has begun moving from science fiction toward engineering. Even with revolutionary technology, there is one barrier we cannot ignore. According to Einstein's theory of relativity, nothing with mass can travel faster than the speed of light. That makes light not only incredibly fast, but also the ultimate speed limit of the universe. Could we ever get close? Perhaps. Future propulsion systems based on nuclear fusion, antimatter, or entirely new technologies may one day allow spacecraft to reach a significant fraction of light speed. But crossing 1 light-year in days, or even weeks, remains far beyond anything modern physics allows. The universe doesn't make interstellar travel impossible. It simply demands extraordinary patience. Today, traveling just 1 light-year remains beyond our reach. Our fastest spacecraft would need centuries, or even thousands of years, to complete the journey. But history has taught us something remarkable. There was a time when crossing an ocean seemed impossible. Flying across the sky seemed impossible. Landing on the moon seemed impossible. Every generation has expanded humanity's horizon. Perhaps interstellar travel will become the next chapter. Maybe not in our lifetime, or even in the next 100 years. But every new telescope, every new spacecraft, And every scientific breakthrough brings us one small step closer. Because every great journey begins with understanding the distance. And perhaps, one day, humanity's first voyage to another star will no longer be a dream. It will simply be the next mission.